Hello friends, welcome to my channel Learn Chemistry with Modcare. In this video, I will tell you about distinguish between functional groups in organic chemistry. The weightage of marks out of 70 to this type of question is 2 to 3 marks. Whenever we have to write answers for such questions correctly, we should keep in mind three things to be mentioned in the answer. These three important points are: first is the name of the chemical test. So you have to mention as headline name of the chemical test. Second is which functional group will respond positively, means give observation with that in the test. And third is the correct observation like color or smell. And finally you have to write the equation also for the functional group that gives positive test. So as these chemical tests are basically practical based, so observation can be either odor, smell, color change or precipitates formation like that. For example, if the question is distinguish between chlorobenzene and benzyl chloride, then as we know, chlorobenzene is haloarine and in benzyl chloride the halogen is not directly linked to benzene ring. So the basic fact by using which we can distinguish between these two compounds is that the haloarenes do not undergo easily nucleophilic substitution reaction, whereas aliphatic halides can undergo. So by reacting with aqueous KOH solution followed by reaction with acidified silver nitrate can be used to distinguish between chlorobenzene and benzyl chloride. Here chlorobenzene will not undergo nucleophilic reaction with aqueous KOH, whereas benzyl chloride does to release chloride ion. These chloride ions released then react with acidified AgNO3 solution added to give white PPT of silver chloride. So then you have to write the chemical equations. First, here benzyl chloride is reacted with aqueous KOH. It forms benzyl alcohol plus KCl in solution. Chloride ion then reacts with silver nitrate in presence of dilute HNO3 to give white PPT. On the other hand, chlorobenzene do not react with aqueous KOH, so it will not give white PPT in the reaction mixture. So how to prepare for such questions in organic chemistry? Generally students, what they do, they take important distinguish between from past papers, sample papers or any other books. But we should not try to cram by studying for different functional groups or compounds, but it is better to prepare such solutions by understanding the chemical test, means the nature of functional group that gives a chemical test particularly. So there are in total 12 chemical tests in +2 organic chemistry which can be used to distinguish between different functional groups. These 12 tests are: first is, as mentioned earlier, reaction with aqueous KOH and acidified silver nitrate. Then we have Yukos test, then ferric chloride solution test. Yukos test is used to distinguish between different types of alcohol, that is primary, secondary or tertiary. Ferric chloride solution test is used to distinguish between aliphatic alcohols and aromatic alcohols. Bromine water can be used to identify aniline or alcohol. Then is 2,4-DNP test, 2,4-dinitrophenyl test, which is given by carbonyl compounds that are aldehydes and ketones. Similarly, 6th test is tolerance region test. It is used to identify aldehydes or distinguish aldehyde from other functional groups. Failing solution test. It is used to identify aliphatic aldehydes. Then we have iodoform test, very important test. It has many applications as it can be used mainly to identify methyl ketones. Then after iodoform we have sodium hydrogen carbonyl test. It is given by carboxylic acid, so it can be used to distinguish carboxylic acid from other functional groups. 10th test we will discuss is esterification test, which can be used to distinguish between alcohol from other as well as carboxylic acid from other functional groups. Then we have carbylamine test, which can be used to distinguish or to identify primary amines from other compounds. Hinsberg test, which is used to distinguish between primary, secondary and tertiary amines. So these are 12 tests we will discuss in the videos here. So first of all, let us go with a reaction with aqueous KOH and followed by the reaction with acidified silver nitrate solution. As already I told you, this test is based on the fact that aliphatic halides undergo nucleophilic substitution reaction whereas aromatic halides do not. So aliphatic halides on reaction with aqueous KOH release halide ion like chloride, bromide or iodide in solution, which on reaction with acidified silver nitrate, that is silver nitrate plus dilute HNO3, give characteristic property of the silver halide. If chloride ion is present, the PPT color is white. If it is bromide, then it is cream yellow color, and if it is iodoform iodide ion, then yellow PPT is formed. So not only we can distinguish between aliphatic and aromatic halide, we can also distinguish between aliphatic halides with different halogen atom, that is chloride, bromide or iodide ion. So vinyl halide and haloarenes, in which we know due to resonance there is partial double bond factor between carbon and halogen atom which do not separate easily. This reaction will not go and no nucleophilic substitution can take place here. So no halide ion released in solution, hence no PPT will be observed. For example, a general equation we can represent here Rx, alkyl halide reacted with aqueous KOH gives alcohol plus Kx. X anions in solution react with acidified silver nitrate and gives silver halide which is insoluble and settles as PPT. So I already told you white PPT, then chloride ion, cream PPT, then bromide ion, and if it is yellow PPT, then it is an iodide ion. So these are the list of organic compounds that can be distinguished by using aqueous KOH acidified silver nitrate reaction, and here all which I have mentioned in red, they do not give this test. You can see in the last, that is 6 and 7, alkyl halides with different halogen atoms are there which can also be distinguished by using this test. So you can try this test if any of these distinguish between comes in your exams. Let us discuss now second test, that is Yukos test. In Yukos test we do reaction of alcohol with a mixture of concentrated HCl and zinc chloride which is known as Yukos reagent. So this Yukos test, in which we react the given sample with Yukos reagent, we can distinguish between primary, secondary and tertiary alcohols. Here how we will distinguish, that is, it is based on the difference of the reactivity order of different alcohols with Yukos reagent, that is towards nucleophilic substitution reaction. Again, here the product formed will be from alcohol will change to alkyl halide, and we know alkyl halides are sparingly soluble in water, so it will produce a turbidity in the solution, and the time taken to appear this turbidity in solution will help to know whether it is tertiary, secondary or primary alcohol. The order of reactivity toward of reaction of different alcohols with Yukos reagent is tertiary fastest, secondary slow, primary slowest. So tertiary alcohol will give immediately turbidity as we mix the tertiary alcohol with the Yukos reagent. On the other hand, secondary alcohol will give turbidity in 3 to 5 minutes, and primary alcohol will not give turbidity even after 5 to 10 minutes. For example, we can use this test to distinguish between propane 1-ol and propane 2-ol. Here propane 1-ol is example of primary alcohol and propane 2-ol is example of a secondary alcohol. So propane 2-ol, when reacted with Yukos reagent, it will form 2-chloropropane and it will give turbidity in 5 minutes. On the other hand, primary alcohol propane 1-ol, when we react it with Yukos reagent, no turbidity is observed even after 5 to 10 minutes. Similarly, you can try this test to distinguish between the following organic compounds. Here again, the compounds I have mentioned in red color, they will give reaction faster as compared to other. Then we can also, if we have to distinguish between whether alcohol is aliphatic or aromatic, then we can use two different tests. First is ferric chloride solution test and second is bromine water test. In ferric chloride solution test, it is based on the fact that aromatic alcohols are acidic in nature as compared to aliphatic alcohols, and they react with neutral FeCl3 solution to form ferric salt of aromatic oxide, which gives generally violet coloration in a solution. On the other hand, aliphatic alcohols do not react with ferric chloride to give such violet coloration in a solution. So we can see here phenol, when reacted with FeCl3, will form ferric phenoxide, which will give violet coloration in solution. On the other hand, ethanol will not give such a violet coloration in a solution. Similarly, you can use this test to distinguish between phenol and benzyl alcohol. Here, phenol will give violet coloration and benzyl alcohol will not give. Then we have bromine water test. So this test gives same observation when we use it by using primary aromatic amines, that is aniline, as well as aromatic alcohols. Because in aromatic alcohols and in aromatic amines, OH groups and NH2 group respectively, they act as activating groups towards nucleophilic substitution reactions and give 2,4,6-tribromo substituted product with the bromine water. The compound formed here may be 2,4,6-tribromophenol or 2,4,6-tribromoaniline is insoluble in water, so it gives a white PPT. So all aliphatic alcohols and aliphatic amines will not give white PPT, whereas aromatic alcohols and aromatic amines will give white PPT when we add dropwise bromine water. So you can write the reaction like this, that phenol reacts with it to form 2,4,6-tribromophenol and aniline reacts with bromine water to give 2,4,6-tribromoaniline, and in both cases we will observe white PPT. So this is a list of compounds where you can apply bromine water test to distinguish between different organic compounds. All compounds mentioned in green will give white PPT in bromine water and others will not give. For details of other tests, you can watch part 2 of the series. Thank you. Have a nice day and fruitful learning. Welcome to my channel.